we're going to talk about spanning trees, Kruskal's algorithm, and Prim's algorithm. The IB Vodcasting has 3 videos which are excellent, so I'm not going to talk about this here. You might want to hit pause if you want to copy mine down, but this video explains it extremely well. The one thing I will say is spanning tree. This is what we're going to be focusing on 15F. Okay, and it has the smallest weight, and we're going to talk about that. So let's first start off with um, uh, Kruskal's algorithm, and we're going to be using these 3 things to help us use his algorithm. So first thing is you're going to pick the edge with the least weight anywhere on the graph, add the edge of the least weight that has not already been selected and does not form a cycle, and then we're going to repeat the stage until all of the vertices are connected. Because basically a tree is something that connects the graphs, has no cycles, and connects all the vertices together. Okay, so Pablo explains this page very, very carefully. I like how he ticks off as he thinks. So now we're going to do the example that he did not do, which is example 6 from the textbook. Okay, so the first thing we're going to do is find the edge with the least weight anywhere on the graph. So notice that there's a few edges that have the 3. I'm just going to pick one at random. I'm going to pick BH. Okay, so the first thing I'm going to do is I'm going to draw B and H. Okay, and I'm going to do like what Pablo suggested. Just write all the letters here: A, B, C, D, E, F, G, H, and as I pick 2 letters that I've used, I'm going to check it off the list. So I've used B and H. Okay, and I'm going to make a tally of the because we're trying to calculate the least weight from our tree diagram. So BH is equal to 3. Okay, so next, the next smallest weight would probably be, let's just pick another one that's 3. How about D and F? So D and F, and that's the 3. So now I'm going to write D to F, and that's 3. So this is the order that I'm going. I'm going to be writing them in order. So I've used D and F now. So now, what's left? Let's see. D to E. That is also, so I can connect D to E. And that's 3. And then another short one, we have to connect A from somewhere, and it's shorter to go from A to H than from A to B. So I'm going to pick this way here. So A to H, and that's equal to 4. So I've ticked off A, I've ticked off E, what's left? C and G. So the next shortest route is, this is long. It's shorter to go to C from B. So that's 4. So B to C equals 4. And then it's to get, we need to connect these guys together. So we're going to, this is 4, C to D, because everything has to be connected together. I can't have 2 separate non-connected things. Everything has to be connected. We still have to get G here. So G is over here somewhere. And this path is 6, that path is 8, that path is 9, this path is 7. So the shortest connection to G is going to be H to G, which is 6. And what we have just done is we basically have connected all the vertices with the shortest routes possible. And if I add all these together, then we get 27 is our total. And so to answer our question, the weights all cost 1,000 euros each. The cost of connecting each pair is shown below. You find the minimum cost to connect it. So the minimum cost is 27,000 euros. Okay. Pablo explains the Prim's algorithm very, very well here, so I'm not going to explain that. You might want to hit pause to copy this down. He talks about this, but he didn't write it down. So he says the different trees of Prim and Kruskal. He said the trees will look different, but the weights will be the same because they will have the smallest weight possible. But both algorithms are greedy, is what he said, because they take the best available option. Okay, so now I'll do example 7 for you, because Pablo does not do this one. And now we got the same picture, but we're going to use Prim's algorithm. So Prim's algorithm is you're going to select any vertex and add the edge with the least weight adjacent to it. Add the edge of the least weight that is incident to the tree, forming the first step. It does not connect to the vertex already to the tree. Okay. So I'm just going to start with A. Okay, and the smallest weighted line to, or edge to A is H, so that's going to be 4. Okay. Okay, so A and H. Okay, so from H, if I look at my picture, the smallest weight from H is going to be 3. So I'm going to draw a line to B, and that has the length of 3. Okay, so we have H equals 4, HB equals 3. Okay, so from here, the shortest length from here to here is 4, so I'm going to go to 4. B to C is 4. Okay, then from there, the shortest length, not 5, not 8, it's going to be C to D, which is 4. Okay, and then from there, the shortest length, I would call it D to E. That has a length of 3. And then also from D to F, that has a length of 3. And what's left? We need to connect G somehow. And I look here, 6, 8, 9, 7. So the easiest, shortest route is 6 from H to G equals 6. Okay, now this is the same picture as example 7, which we just did a minute ago. If I total this up, I got 27 total, which is the same answer that we just got on the previous one. So the answer is 27,000 euro. But look at the shape of this compared to the one on example 6. It connected it differently, but if you add the totals, this should be the same. Okay. So all the minimum spanning trees will have the same weight, but may not have exactly the same edges that were used. Oh, exam hint: unless you're told to use a specific algorithm, they're not going to care if you use Prim or Kruskal's. Okay. Pablo explains this one here very well, although he does make a mistake. He says that when he's writing it and solving it out, he says the length from B to D. He says the length from B to D is 10, but if you look at the chart, from B to D is 7. So where I've highlighted in yellow is the correct value for B to D. He explains it really well, but he just put 7 instead of 10. Okay. So here's my work on what Pablo did. Okay. Okay, so I'm going to do example 8 with you now. Okay, so if you do example 8 using Pablo's method for this, so the first thing I'm going to do, we're going to begin with A. It doesn't matter which row we begin with, but just being thorough, I'm going to start with A. And the smallest path is A to E. So I'm going to connect A to E. It's not necessary to draw the diagram, but I'm going to anyways. Okay. So now that I've chosen that, we can cross out everything in that row. We can also cross out everything in the A row. Okay. And now I can look at row E, and the shortest path there is 15. So now I'm going to connect E to D, and we know that the length from E to D, the length of that edge is 15. So I've used the edge AE, which is 10, and the edge of ED, which is 15. Okay, so now I can cross out this here, and we can look at this row here. So I'm looking at rows A, D, and E, and we're going to pick the smallest edge. So 40, 45, 15, 20, 30, and 35. So 15 is the smallest edge, and that connects from D to B. So I'm going to draw here to B. That's 15. Okay, and now I can cross out the B row. And now I'm going to look at, okay, I can look at row B now. Okay, so I've got 45, 25, 20, and 35. So what's left, the shortest route is going to be with 20. And 20 connects D to C. D to C. And you add those together, and you're going to get 60 total. Okay. So for reflection, Prim's algorithm systematically makes sure that every point is considered, and they do the direct connection first. Okay, so the next part, we're just homework assignments from the book. So it's likely the exam question will require evidence that you have performed the algorithm correctly. So you'll probably want to draw the tree or whatever. So I'll just do one of each, and show my answer key. So if I start off with picking the shortest edge, right? We're going to find the edge that is the least weight anywhere on the graph. So the least weight edge I see is E to F. So A, B, C, D, E, F. Okay. So I'm going to draw E to F, and that is 5. I'm going to have E to F. Okay. Now I'm going to, the next shortest one that I see on here is F to D. F to D, which is 6. The next shortest one, okay, so I've used E, F, and D. Okay, the next shortest one that I see is CD. Which is 7. So I can cross out C. The next shortest one, I've used these two. Okay, we need to connect A and B. So the shortest next one after that is A, which is 8. So we go from F to A, 8. And then to go from A to B is next, because that's shorter than going from C to B, and that is 9. So what did we do here? We did C to D 7, A to F is 8, and then A to B is 9. Add those all together, and the total is 35. Okay, I'm going to show my answers here. Okay. All right. I'll do this first one here. So we're going to find the minimum spanning tree, list the order of which we're going to do. So, oh my gosh, I just did that using Kruskal's algorithm. Oops, this was Kruskal's. My mistake, my bad. Okay, so let's do prims now. Okay, prims, we start with any one we want to. Let's just start with AF, which equals 8. The next shortest one that connects to either of those, that's 9, that's 13, that's 8, 6, and 5. So E to F, that's 5. Okay. The next shortest one is going to be from F to D, which is 6. The next shortest one is going to be D to C, which is 7. The next shortest one is going to be, we have A, F, E, D, C. The next shortest one is going to be A to B, which is 9. And we add those all together, and we get 35. So like I said, I just did prims here. Sorry for getting it mixed up. Now if we compare our picture to the one, oh, it looks the same. Okay, well, but the order in which I wrote the things might be a little different. Okay, so okay, so here's prims. Here is using Kruskals. Oh, okay, here we go. Okay. So I've gone in order that I made my lines. Okay. Let me do number 5 using Prim's table algorithm. So if we start off with row A, the shortest one is that one here. So we know AD equals 15. I'm going to draw a line from A to D. 15. Okay, I can cross out this. Alright, and I can cross out A. Okay, now I can use row D now. And the shortest value here, 40, 25, 20, 20, 15, 45. So I'm going to, this is the shortest route there. So from D to C is 15. D to C equals 15. So I used A, D, and C. Okay, so now I can cross out the C row, and we can look at row C, and so we've got 40, 20, 25, 35, 45, and 20. So, so I can either go pick this 20, or I can pick this 20. It doesn't matter which 20 I pick. I'm just going to pick this one here. So this 20 goes from D to E. So from D to E, our edge length is 20, or edge weight is 20. So D to E equals 20. And now I can cross out this here. And now I can look at row E now. Wait, yeah, I can look at row E now. So we've got 40, 25, 45, and 30. So the smallest one is 25. So, and that connects B and C together. So there's B, and that's 25. B to C is 25. And now I can add those total, and the total is 75. Okay. Last question. Same process. I'm just gonna, so if I started with A to B, okay, if I started with this, the smallest value there is 4. So that's, I picked that one there. And then I cross out everything there. And then I look at row B and A, and the smallest one is 3. So then I drew the line from B to E, and then I crossed out this guy here. And then now I can look at rows E, B, and A, and the smallest one is that one there. So I'm connecting E to C, so now I'm connecting this one next. And now I can cross out this column. And then the next one, I can look at row C now, and the last thing is the shortest one. Shortest weight is 5, so now I can connect B to D with a length of 5. Okay, and so comment on why it would be more difficult to use Kruskal's algorithm than Prim's algorithm with this information, because it's difficult to check whether adding an edge will form a cycle. Because you're not allowed to have a cycle in a spanning tree.